As a final project, we were given the task of designing, assembling, and programming a CNC machine capable of drawing any image of letter size sheet. The CNC should have 2.5 degrees of freedom. 2 that simply means that the machine controls its movement in 2 axes and has a toggle operation on the 3rd axis. It's a tool must be interchangeable and must be designed by ourselves. The first thing that we did in our building process of our CNC machine is to detail the assembly based on our software of choice, our software CAD of choice, that is Autodesk Fusion 360. In this software, we create each of the following parts of the CNC machine. As you can see here, we have the base, we have the X base, we have base Y, we have some components that allow us to hold correctly, and some components such as screws that allow us to hold our CNC machine. We have some support additional items that allow us to create and manipulate correctly our X, Y, and Z axes. And as we can see here, we also use step motors such as NEMA 17 step motors. And finally, we have our assembly here. So we can see this is our final assembly that allows us to manipulate our X, Y, and Z axes. For this, we buy some components online, such as the screws that we use in the CNC machine, and other items such as the support items. We create them through a 3D printer, as you can see in the following video. For the electronic part of our CNC machine, we use a CNC Shield B3 for Arduino One. This CNC Shield allows us to connect 4 step motors and control them according to the X, Y, and Z axes. Also, 1 step motor for support of one of those axes. Also, we connect the step motors according to the diagram in the screen that allows us to connect those motors. In our case, we connect our support motor with the X axis in order to rotate the screwdriver and allow us to move correctly in the X axis. For the correct calibration of the CNC, we rely on the setup wizard to set up the firmware. To get started with this, we had to initialize by opening the machine menu and then selecting the wizard option. If you are incorrect with your controller, a connection dialog will be presented. The version of the controller will be shown after connecting. The available setup steps will be loaded for the controller. In case there are settings files for the machine manufacturer or there is a backup of those settings, the user may import it here. On the motor wiring configuration page, you can test the direction of your motors and change the direction if needed. On the step calibration page, you can move the machine and measure the actual distance. It will be recommended a step setting for your machine. If you have limit switches, you may be enable them on this page and test if they are firing correctly. If limit switches are enabled, you may enable homing as well. This page helps you configuring out which direction of the homing should be made. If homing is enabled, you may also configure sub-limits so that the controller knows if it can process a command without triggering limit switches. The first thing we need to do to use our platform software, Universal G-Code platform, is to connect all Arduino to the software. We connect to the port, in this case is COM6, and we connect it to the software by clicking connect. Here, as we can see, the icon is in orange, so it is correctly connected. Here we have our control state with the dimensions, and we create a new design here. We name it example 2, and we create our file named example 2. Here we have some options to draw, write text, or do other things. In this case, we're going to import a drawing in SVG to the software. I'm going to upload this called Adidas, and we give the correct dimensions to the drawing. As we can see here, the drawing is outside the dimension of the page. So we're going to select all, move it to the page, and give the correct dimensions that we need to do. Here we have X, Y, width, and rotation. We're going to leave these parameters, and here we're going to click the cut type. We have different cut types according to the type of job that we want to send to the CNC machine. We have pocket, on pad, inside pad, and outside pad. For our CNC machine that we create, we're going to do it on pad in order to the machine to follow the steps and the lines that the SVG file created. We create our step, and the next thing that we need to do is click to initiate the program and send it to the CNC machine.